And the next topic is about the truth table for priority encoder, where in this example, we have the 4 by 2 priority encoder, where we have 4 inputs and or this and 2 outputs, which is A and B. For the V or victory, we're going to check if you have 0 inputs, the valid input will be 0. And when we have 1 input, our valid input will going to be 1. And if our valid input is 0, it doesn't matter what will be our output or what will be the A and B. And in priority encoder, we're going to have what we call a highest value or a highest priority, highest priority and lowest priority. In this example, we just indicate that D3 will have a highest priority and D0 will have the lowest priority. We have inputs, which is 0, and then because the inputs is 0, the valid input will be 0, then the output, it doesn't matter what it outputs. The next one, we have D0, and because we have an input or one input, our valid input will be 1. Then our output will be 0, 0. And the next one, D1 is our input and the valid input is 1 because we have an input and the output will be 0, 1. This. Then the next one is our input will be D2. Valid input will be 1 because we have an input and the output will be 1, 0. Then the last will be the input is D3. The valid input is 1 and the output is 1, 1. The next input we have 2. We have 2 inputs. Like we have an input for D2 and an input for D0. So this is the priority encoder. Differentiate from just an encoder because we have highest priority, and lowest priority. So if D3 is our highest priority, D2 will have higher priority for D1, higher priority than D1. So it doesn't matter if you have D2 and D0, it doesn't matter if the D0 have an input. The D0 will be, or doesn't matter what it will input because a high priority is D2 in this case. The output will be just 1, 0. To get this output, we just think about the input as a decimal and the output is its binary value. Like D1. In D1, in 1 or 1, number 1, if we convert it to binary number, it will be 0, 1. And D2, our number is 2. So, our binary value is 1, 0. Or the output will be 1, 0. And D3 or the 3 value which is in binary is 1, 1. We go to the 8 by 3 priority encoder. So, it's just the same concept for the 4 by 2 encoder. We have to indicate what will be our highest priority still and the lowest priority. Just like that. Then, if you're asking why or how it will have the out or how will we compute the output, we just have to have a base 2, and then we have an n equals to 8. So what value can we give n or exponent n to have as a value of 8? So we just have that 3. So 3 or n is our output. For the 4 by 2, the same computation, base 2, then exponent n. What what we can give the exponent n for us to have an answer of 4. So we just have the 2. Then n is equals to 2. Then our output will be 2. Just like the first table, if our inputs are 0, our valid input will be 0, then it doesn't matter what will our output will be. Just like the same as the 4 by 2, we're gonna jump to the D4. So in D4, we have valid input 1, then our output will be 1, 0, 0. So if you want to know about this, we have this is the value of the output 421. So for D4, which is the number is 4 and number is 4, so we're going to insert 1 under the 4. Then the rest will be 0, 0, 0, 0, and 0. So our output will be 1, 0, 0, 0. If our input is D5, output will be D5. So 5 going to have 4, 1 under the 4, and 1 for the under the 1. So if we plus or we add 4 and 1, 4 plus 1 will be 5. So that's how we get the value of this 8 by 3 priority encoder. So because Because of highest and lowest priority, if we have a D7 as our input, it's because it have the highest priority. It doesn't matter what is the input of the rest, low of the rest of the input lower that have lower priority than D7. And that's how priority encoder works, or the two table for priority encoder works.